Hi guys, my name is Vaishnavi. I'm studying in Sri Venkateshwara College of Engineering. I'm going to explain about bisection method and Lagrange's inverse interpolation. Introduction: Efficient root finding. Exploring the bisection method and Lagrange's inverse interpolation in mathematics. Finding the root of an equation is a common problem. This presentation will explore two methods for finding roots: the bisection method and Lagrange's inverse interpolation. What is the bisection method? The bisection method is a numerical method for finding the root of an equation. It works by repeatedly dividing an interval in half and selecting the subinterval in which the root lies. This process is continued until the desired occurrence is achieved. How does the bisection method work? The bisection method works by calculating the midpoint of an interval, evaluating the function at that point, and then selecting the subinterval in which the root lies. This process is repeated until the desired occurrence is achieved. Advantages of the bisection method. The bisection method is simple to implement and granted to converge to a root. It is also relatively intensive to the initial guess and can handle functions that are not differentiable. Disadvantages of bisection method. The bisection method can be solved to converge, especially for functions with multiple roots. It also requires that the function change sign within the interval, which may not always be the case. What is Lagrange's inverse interpolation? Lagrange's inverse interpolation is a numerical method for finding the root of an equation. It works by interpolating the inverse of the function and then finding the root of the interpolating polynomial. How does Lagrange's interpolation works? Lagrange's inverse interpolation works by interpolating the inverse of the function using a polynomial. The root of the interpolating polynomial is then used as an estimate for the root of the original function. This process is repeated until the desired occurrence is achieved. Advantages of Lagrange's inverse interpolation. Lagrange's inverse interpolation can converge faster than the bisection method for certain functions. It is also more accurate for functions with multiple roots. Disadvantages of Lagrange's inverse interpolation. Lagrange's inverse interpolation can be more difficult to implement than the bisection method. It also requires that the function be invertible, which may not always be the case. Bisection method versus Lagrange's inverse interpolation. Bisection method is good for function with intervals of uncertainty and unknown roots. Lagrange's inverse interpolation is better for function where the y value with a corresponding x value are unknown or the inverse of a function is required. Both methods have limitation and should be used with depending on the type of function being approximated. Particle applications. Bridge engineering used by engineers to calculate the volume of a bridge per required to prevent scoring of the river bed. Pharmacological used to calculate the dosage of medicine required for a given concentration in the blood. Satellite communication used to estimate the effect of position error or delays so that satellite can be positioned correctly for data transmission. Mastering numerical methods. Numerical methods are critical in solving complex mathematics and scientific problems. To master these methods, you need to understand their strength and limitations and know when to use each method. Hopefully, this presentation has provided clarity on the bisection method and Lagrange's inverse interpolation. Conclusion. Both the bisection method and Lagrange's inverse interpolation are useful methods for finding roots of equations. The bisection method is simple to implement and guarantee to converge, while Lagrange's inverse interpolation can converge faster for certain functions. The choice of method depends on the specific problem and hand. Thank you.